going to be completing this little exercise that I've put together, obviously put together myself. I'll go ahead and feed forward and let you know that I'm doing this in numbers. In numbers, it seems like it doesn't work the way either it used to when I did it in Excel, or maybe because I made it in Excel and I pulled it into numbers. It's not quite doing what I would like for it to do, but it's an easy workaround. For one thing, I think for many of you doing this yourselves on Excel, it will do what I would like for it to do, although I'm not sure because I'm not doing that. But it's all fine because in the version I'm going to post soon, you'll see this extra tab up here, this extra worksheet, and that's where it's all completed anyway. So I'm going to go through and show you how to complete it. Really, what I like to do in face-to-face is I just have this printed out and we use pencil and paper and we do this with calculators, and we get plenty of practice at calculating these things. The upside to computers is they do make life often simpler, and we can do a couple calculations and copy and paste the rest. The downside is it doesn't always do what you want it to do, what you think it should, and that's what I'm facing here now. So we'll overcome. I think it'll be fine. The main event here is learning what these variables mean and how they interact. So let's start with this one right here, MPL. What that stands for is the marginal product of labor. For us, marginal means changing, and going from one place to the next along these graphs is how we might think of marginal. So nothing can happen in this cell because there's no change. But in this cell, something has changed. When we're talking about the marginal product of labor, we're talking about that production function where we have output increasing as a function of bringing in more workers or working more hours. So what I want to know is, what does this worker bring? Now that's pretty easy by looking at the numbers, so let's go ahead and overcomplicate it for just a second and do it as a function. That way we get to practice doing the math for when it's not so easy. So I'm going to hit equal sign, and in Excel or in numbers, that's how you enter a function. Okay, I like parentheses. Parentheses seem to be my friend, so I use them often. Sometimes maybe more than I need, but I'll insert them to be on the safe side. So my marginal product of labor, that is equal to my change in output due to some change in labor. Now here I'm only going up by one laborer at a time, so I'm always dividing by one. So I'm overcomplicating this, but it's not always that way. So that's why I'm overcomplicating this, because it's not always that way, and sometimes you might be going up by more than one. So my change in output is my new level of output minus my old level of output. So it's this cell minus this cell. That's my new output over my old output, or minus my old output, right? I'm going to close out those parentheses, and that's going to be given some change in labor. And since I'm focused on labor at the bottom, I'm going to open parentheses, and my new level of labor is 1 worker, where I used to have 0. So I'll do it like that, and we are going to get to 10, as was fairly obvious. Now, if you did this on Excel, I believe you would have had a point come up down here, like that. But something is not, there's a ghost in my machine here and it's not doing it. But that was my hope. If not, you could plot a point. One worker, with one worker there are 10 units produced. Now let me do this again, just for good measure. Let me move this out of the way so you can see what's going on here better. When a second worker comes in, the total output rises to 23. So my change in output is now this cell, or 23, minus what it used to be was 10, and that's what's in this cell, and that is over. My new number of workers is this cell 2, minus my old number of workers was just the 1 that's in this cell. So I can do like that and hit enter. And that worker's the marginal productivity of labor of the second worker is 13 units. Now let me just do this one other way, where instead of clicking the cells, I'll enter the numbers that are there, because it will work the same. I still hit equal, and that tells Excel or numbers that you're going to be entering a function. And now I'm just going to type it in. My new number of units of output is 29. I could have clicked that cell, but I could type in what's there if I want to. Minus my old is 23. Now we all know that's 6. And then that is over my change in workers, which is 3 is my new number of workers, minus 2. We all know that is 1. And I think we all know that 6 over 1 is 6. So we could do it by typing numbers, or we could do it by clicking cells. Do whatever works for you. Like I said, if it were up to me, we would be doing this on paper with pencil. Whichever way I choose to do it, I think this way is kind of neater. I'm going to hit Command C in a Mac, Control C on a PC. Then I'm going to hit Command V. And now I have filled in the rest. That's just doing the same operations I was doing up there. And that's my marginal product of labor. And if it was filling in the graph, it would look like that right there. And so that shows, this is called a production function. This shows us that output rises as we add laborers, but it increases at a decreasing rate. That change in rate is our marginal product of labor. And here I had it going negative because the workers are quote unquote tripping over each other. My next variable I want to investigate is MC. Guess what MC stands for? Marginal cost. Marginal again means change, so nothing can be happening in the first cell because there hasn't been any change yet. Now, with all of these things over here, we are no longer concerned with this column. The labor column is only useful for the production function for the things we're doing. It's a common mistake to go back to this one because it's the one on the left and it's the one that we worked with and it's the one you probably feel comfortable with because it's close to drinking lemonade. But we're not working with that anymore, so don't do that or you'll have mistakes. Big mistakes. Nothing will make sense. Now we're interested in costs as a function of quantity. So I'm going to be going to this column. Remember, quantity is on the bottom of everything that we're doing in one way or another. So marginal tells me it's a change. So I need to start with the second thing. Change to what? Well, cost is what we're talking about. C for cost. So it's my change in cost. And Q is going to be on the bottom, but we're talking marginal, so we're talking about a change in Q. So what does this equal? This equals, let me move it out of the way so you can see more clearly. I like parentheses. My new cost is 80 minus my old cost of 30. We all know that's 50. Divided by my new number of units of output. I almost said the wrong thing. My new units of output minus my old units of output is my change in output, my change in Q. And now I'm going to hit enter. And something went wrong. I changed in D13. Move this out of the way. Move this out of the way. D13 is 80 minus D12 should be that 50. Oh, I see what I did wrong. That was a simple boo-boo. I like parentheses, but not enough. Okay, 5. Now let's repeat that and make sure it makes sense. This is marginal cost means it's going to be a change in something. What cost? The marginal tells me change. This tells me a cost. So my total cost rose to 80 from 30. That's a change of 50. My marginal cost is a function of the number of units. My units rose from 0 to 10. So 50 over 10 is 5. That makes sense. So let me try it without clicking the cell so you can see the numbers. Perhaps that'll help with understanding. So this marginal cost, to go to the next level of output that we have information about, is going to be equal to my new costs, my total costs are 130. And they came up from 80. My change in output is still here, so it's a matter of going to the right column, the correct column. My new level of output is 23, and that came up from 10. I'm going to double check, make sure I haven't missed any parentheses this time. I did not. And 3.8 something is what I get. So my bills went up by $50 when I made another 13 units. 15 divided by 13 sounds about, 50 divided by 13, well, be somewhere under 5. Sounds about right. Let's see what I had in the past. Yes, I already have it, so good. No boo-boos there. So let me do another one, just for more practice. What's going to be my change in total cost? The difference here. This happens to be the same. It's not always going to be that way. I think when I set this up, I was thinking each laborer costs $50. So that's why I made it consistently 50 on the top, but it's not always that way. So let's go back to clicking the cells. My new cell is this, minus my old cell was that. Remembered my parentheses this time. Don't go here. I almost did it, but it's not what I want. I'm looking for the quantity as the control variable. So the new quantity is 29, minus the old quantity is 23, and I know that's 6. So we're talking about 50 divided by 6, and 8.33 sounds exactly right to me. Now that I've done that, I will hit Command C or copy, and I'll fill in the column. And to make sure I'm not continuing on in a video having made a mistake, yep, there we go. I have this negative sign here. That's because I tried to get cutesy, and I actually went to where the marginal product of labor is negative, just because it's sort of fun for me to think about people who work at the donut shop sort of misbehaving and actually producing less, having more workers. We don't usually do that. I was just trying to be a little bit funny. So let's just get rid of that. That's not something that we have to worry about. Now, the next column here, TFC is total fixed costs. Some textbooks say total fixed costs. Some just say fixed costs. It's kind of redundant. I'm not sure why I chose to keep it on here because most of the time that's not my habit. I think I was just trying to make it more consistent with the other labels. So total fixed costs are fixed costs. Now this is fixed. So how can I figure out what goes here? Well, fixed means not variable. And if you notice, here we aren't producing anything. Yet there's a bill. So what's fixed costs? 30. Because you're paying that even if you're not producing anything, so it must be a fixed cost. And the cool thing about fixed costs is they're fixed, so you can just copy that all the way down. It's going to be the same. Okay, so we know here, if the bill was 30 and nothing was made, variable cost must have been 0. TVC stands for total variable cost. But here, total cost rose to 80. Total costs must be equal to variable costs plus fixed costs. Those are the two kinds of things there are to reach a total. Well, if fixed costs were 30 and total costs were 80, could we say what variable costs must have been? Well, if there are only two things they could be, it must be equal to total cost minus total fixed cost, 50. Let me do that again. This time I'll do it with the numbers. This has to be, since total cost is always fixed cost plus variable cost. Here I did change the name up a little bit. I put a T in front of it, but it's the same thing. Okay. Since total cost is the sum of those, it must be total cost minus the one you know is the one you don't know. So this is equal to 130 minus 30, which I think we all know is 100. I'll do it one more time with the cells. This is equal to total costs minus total fixed costs. 180, I'm getting 150 in my head, indeed. And I will stop doing that. Now to make sure I'm not continuing on in a video having made a mistake and not noticed, let me just be sure. And those numbers all line up with what I had done in the past. Cool. That's how we can get there. Now average total cost, average variable cost, and average fixed costs. People get all shaky in the knees about these things because there's so many things here. They say, what do I need to memorize all these formulas for? These really aren't formulas. They're more like relationships. You do have to know what the terms mean, though. Total means the sum of the other things, right? Total cost is the sum of fixed costs and variable costs. Average, ATC stands for average total cost. Well, average total cost is still just having Q in the bottom. Everything that we've done like this, and this, they all have Q in the bottom. If it says average, it means just Q. If it says marginal, that means the change in Q is what's in the bottom. If it says marginal, it means the change in the other thing. Right there, C for total costs is what's in the top. If it says average, it means the other thing in it is what's on the top. So what I'm saying is average total cost, I'm not allowed to divide by 0, so I'm going to skip that one and I'll come back to it and explain in just a second. Average total cost is equal to total cost divided by quantity, because Q is on the bottom of all of these, and the thing on the top is the other thing that's in the thing you're being asked for. So this is equal to this divided by this, 8. In other words, that's your cost per unit. Let's step away from all this math and all this Excel kind of stuff and think about what this means. When your bills are $80 and you're making 10 units, your cost per unit is $8. Let's do another one, and this time I'll just use numbers. All right, I said I'd come back to this. Here we go. I can't divide by 0. Q is in the bottom, not allowed to divide by 0. It's against the rules of math, so that just remains blank. Now, average total cost when you're making 23 units. Well, when you're making 23 units, your bills are $130. So your average total costs or your cost per unit is $130 divided by 23. Average total cost is a fancy term for cost per unit. It's costing you that. Let's do this one. I'll go back to using the cells. Average total cost is cost per unit, so that must be your total cost divided by the number of units you're making. $6. Let me hit Control C, fill in these other couple values. And sure enough, average total costs fall for a while and then they start to rise. Average variable costs. So average variable cost, if you're saying, well, how do I calculate that? Average tells you Q is in the bottom, just Q. This part right here tells you what's in the top, variable cost. So this is equal to the variable cost divided by the corresponding quantity that made it so. Let me fill it in with numbers. This one then. When you're making 23 units, your variable costs are 100. So your average variable cost, your variable cost per unit is 100 divided by 23. And I'm just changing up, rather than clicking on it, I'm just changing up and entering the numbers so you can see that it's the same thing, or it could go either way. I could do it again that way. Your variable cost per unit is what average variable cost means, and if your variable costs are 150 when you're producing 29 units, your variable cost per unit is $5.17. So I'm going to Control C, paste. Now, average fixed costs, let's think about what that should look like. This is your monthly bills. As you make more and more units, the contribution to your monthly bills per unit is just falling. It should always be falling, because how much does a unit pay of your rent? Well, if you only make one unit, you need that unit to pay all of your rent. But if you make 1,000,000 units, each one's adding a smaller contribution to your rent. So the rent per unit is always going to be falling, and average fixed cost, or fixed costs, that's like rent. It's something you have to pay even when you don't produce anything. Remember that? So let's start with this one. Your average fixed cost, or to think of it in terms of a formula, average means Q is on the bottom. The other thing is right here. Your fixed costs are 30 when your Q is 10. So this is this divided by this. Be careful to click on the right thing or it gets weird. I almost clicked on the wrong 10, didn't I? Here, this is your fixed costs divided by the number of units to make those, what's going on there with those fixed costs, 23, and it's going down. And it should be going down throughout. And it is down, down, down. So that's how you calculate each of those. Now, if your sheet is working like I hoped it would, or if it's not, then you can do this. But this is what they end up looking like. Added data references. It's just not loading properly in mine because I changed over from IBM base to Mac. These are pretty typical curves, what they should look like. What's going on here is this dark blue line is marginal cost. And I can make this bigger. That's one thing that's nice about it. Marginal cost always crosses average total cost where? At the minimum of average total cost. Average total cost is always shaped somewhat like a parabola, and marginal cost will always cross it at the minimum of it. Average variable cost is also generally shaped like a parabola, and it will be crossed at its minimum by marginal cost because the marginal cost is driving those things up anywhere that it's above it. Average fixed cost is always going to be shaped like this, and I don't draw it too often because it's kind of ho-hum. It's always shaped like that. There's nothing going on there. It starts off very high and it asymptotically approaches zero because as you make more and more, dividing up your monthly bills, your fixed costs by the number you're making will always approach zero. It'll get smaller and smaller. So that's what these curves should look like. If you have an Excel version, if you're working on Excel, then my thought was if you wanted to change something, I don't think mine's going to work, and say this worker actually did make more or something like that, made like 37 units. Yeah, it didn't do anything, did it? I don't think it did anything. Let's make it crazy and I'll be able to tell. It did, yeah. If you want to, the beauty of this is that if you want to tinker with it, you can plug in different numbers and see how the curves interact. You can make them all change like I just did there. Whoa. See that? So that was why I kind of wanted to have the curves moving in real time so you could see those changes if you wanted to. It also, even as it is, helps you to see what the curves look like. Down here is the first curve that we did when we discussed this, the first set of curves. I didn't do fixed costs in my discussion because, well, oh yes I did. I didn't do variable costs. Fixed cost is just this flat line. The variable cost is just running asymptotically close, or I'm sorry, it's not running asymptotically close. It's running just the difference between total costs and total variable costs is the height of fixed costs. Why? Let's think this through. Because total cost is the sum of variable costs and total costs, fixed costs. I don't know where the fixed cost disappeared from in my label there, but that's total costs. This is total fixed costs. That's total variable costs in yellow. And the gap between the yellow and the green is exactly the height of the gap between the red and the axis because they sum to that. Another little tricky little thing, neat little thing. Check this out. We already did total cost is equal to total fixed cost plus total variable cost. So 30 and 50 equals that 80. 30 and 130 equals that 130. 180 minus that 30 is that 150. That's the relationship there, but check this out. Look at these numbers. Your cost per unit is equal to your average variable cost plus your average fixed cost, isn't it? 8 is equal to 5 plus 3. You think that's a coincidence? This isn't as obvious to see, but 5.65 is equal to 4.35 plus 1.3. Check it out, it is true. Here's one that's easy to see. $10 is your average total cost. Your average variable cost is $9.09. Your average fixed cost is 91 cents. What do you think 91 cents plus 9.09 equals? $10. Coincidence? Nope. But if you think back to what these formulas are, they're these things, all divided, each divided by Q. Well, if you think about adding fractions, you add and subtract fractions by having the same thing on the bottom, and these three things all have Q on the bottom. So of course they add and subtract to each other, just like they do over here when you don't have Q on the bottom. I know you cannot get such elegance out of your sociology classes or your psychology classes where things just intertwine so together like perfectly cut puzzle pieces like you can here. I know you can't. I hope that was a little bit funny. And I hope this thing was a little bit useful. Now I'm going to try to make it stop.